Okay, in this problem 45, we have the brick that's sitting on top of two cylinders. We have the ratio between the size of the two cylinders, or the area of the two cylinders. Young's modulus is different for the two cylinders, but we got a ratio of those. They're identical lengths before the brick was placed on them, and they are identical lengths after the brick is placed on them. So what fraction of the brick's mass supported by cylinder A and what by cylinder B? Horizontal distances between the mass of the brick and center lines of centers of DA are in DB, and what is that ratio? Okay, so part A. What do we know? We know that let's call FA is the force on area A, which is Young's modulus A times delta L. Oh, let me put a space in there. Delta L over L. Right? We also know that force B, AB equals EB delta L over L. And if I solve these for delta L over L, we get, what are we after? Okay. What fraction of the mass supported by cylinder A? Okay. We know that FA plus FB has to be mg, right? Has to be the weight. Okay. So delta L over L. In both instances, we got FA over AAEA, and we've got FB over AB EB, right? Those are equal. So FA is FB times AA over times, let me get this right, AA times EA divided by AB EB. All right, but we have these equations. AA is 2AB, and we have EA is 2EB. Right, so if I stick in for these two, all right, if I substitute in for those, that gives me FB times, all right, 2AB. It's going to give me a 2 in the denominator, and the AB in the numerator, in the numerator, AB in the numerator and AB in the denominator are going to cancel out. If I put in EA right up here is 2EB, I'm going to get the same thing, and so I get FA is 4 times FB. All right, FA is 4 times FB. Okay, we also have, I did the one equation, FA plus FB is mg, and if we look at the torque, right? If we look at the torque about, I'm going to look at the torque about the center of mass, we get FA times dA equals FB times dB, right? The torques are equal. And so if I look at, all right, so what am I asked for first? What fraction of the brick's mass is supported by cylinder A? Okay, so I'm going to take FB equals 1/4 FA and substitute it into this equation, right? And that's going to give me FA plus 1/4 FA equals mg. And so FA is, what is that, 5/4? Okay, 4/5 of the weight, right? That's part A. Part B, I'm going to take the same equation, FA equals FB. I'm going to stick in 4 FB for FA plus FB equals mg. All right, and that's going to give me FB is 1/5 of mg. That's great because that's 4/5 and that's 1/5, right? Finally, from part C, for part C, I'm going to take the torque equation, which was this, right? Take the torque equation, and I'm going to solve for dA over dB. Is that the ratio it asks for? d over dB, right? So dA divided by dB is just going to be FB divided by FA. Now, FA is 4FB, right? So this is 1/4. FA, make sure I find it again. Yes, well, it's here somewhere. There it is, right? FA equals 4FB. Okay, FA is 4FB. I stick that in here for FA, and I get 1/4 is the ratio dA to dB. And that would be it for this problem.